Welcome back to Algebra with Miss Swartz. Today we're going to be looking at special solutions for systems of equations. Yesterday we started off with our first day of systems of equations. We talked about how systems of equations are just two or more sets of equations, and a solution to those equations would be an ordered pair that fits both equations or all of the equations that are involved in the system. We discussed that there was many ways to solve systems of equations, but we focused on graphing yesterday, and we're going to continue graphing today. We're going to look at what the graph for special solutions of systems of equations looks like, and we are going to just continue working on graphing. Some of us still have a little bit of troubles with that. So our question of the day is, can systems of linear equations have no solution or infinitely many solutions? Well, remember when we were talking about systems of equation yesterday, my pen to work here, we would graph two lines and we would check where they intersect. That would be our solution to our equation. Well, if you think about on a graph what might cause you to have no solution, okay, what if they never intersect? Okay, what would it look like? What would it look like if they never intersect? Well, they'd probably be parallel lines, because parallel lines never intersect. So we're going to talk about that on graphs. And then infinitely many solutions. Well, if we have one solution here, for them to have infinitely many solutions, they'd have to cover each other up, right? They'd have to be the exact same line. So these are kind of what we have. Parallel lines are going to give you no solution, and the exact same line is going to give you infinitely many solutions. So that's what this chart shows. It's actually in your journal on page, looking for it right now, 148, or excuse me, 149. So it shows a system of linear equation can have one solution, no solution, or infinitely many solutions. It shows lines are intersecting when it's one solution, lines are parallel when it's no solution, and the lines are the same when it's infinitely many solutions. So we're just going to work on graphing. We're going to look at these examples, and we'll go from there. So let's get started on some examples. Okay, so you need some graph paper, obviously. You're going to be graphing. Hopefully you can use a piece that you got yesterday. To solve the system of linear equations, we have equation 1 and equation 2. In equation 1, our slope is obviously 2, found here. Our y-intercept is 1, found here. For equation 2, our slope is also 2, but our y-intercept is at -5. Okay, so this could maybe give you a hint right now what this is going to be, but we're just going to work on graphing. But if you know anything about slopes and parallel lines, you might already kind of know what's about to happen. So if my y-intercept's at 1, I plot it at 1, and then my slope is 2, I'm going to go up 2 over 1. This is good practice for some of you. The fact that you can go down 2, but that means you have to go left 1, because a negative over a negative is positive. So I have this positive slope going up. Okay. My next point's at -5. And I have a slope of 2. I'm going to go up 2 over 1, up 2 over 1. Okay, I can go down 2, left 1. So again, my slope tells me which direction I should be going. I should be going positive up from left to right. So if you can see, these two are parallel lines. They're never going to cross. They're never going to intersect. So since they're never going to intersect, we can say that this system has no solution. And you may be able to spot that ahead of time, but I do want you to practice graphing today. So on your homework, you'll need a graph piece of paper, because there's about 9 problems that you're going to be doing where I want you to graph to solve the system. Okay, so let's jump to the next one. All right, so now, again, we have to work on changing to slope-intercept form because we really do want to know our slope. So we're going to add 2x to both sides, and we practiced this in bell work today. So we get y equals 2x plus 3. And for this one, we're going to add 4x to both sides, so we get 2y equals 4x plus 6. I'm not quite done because I got to get y alone, so I'm going to divide by 2, and I end up with 2x plus 3. So again, if you notice something here, we have a slope of 2 and a y-intercept of 3. Here we have a slope of 2, y-intercept of 3. So I'm going to graph this. Okay, if I start with the first one, I'm at 3, up 2 over 1, up 2 over 1. Okay, there we go. Can't draw as great of a straight line there. But if you notice, my y-intercept's at 3 again, and my slope is the same. So what we have here is the same exact line. I don't really need to draw 2 lines of that. I have the same line, so this is going to be infinitely many solutions. All real numbers, either one, whichever you choose to pick. Sorry about that. So when it's the same line, when we get to this point and we have the same equation, we know that the system here is going to have an answer of infinitely many solutions. Okay, we're going to try one more together, and you're going to try one on your own. We're going to try number 1 together. So I'm going to get x or y alone, excuse me. So y is equal to negative x plus 3. Same thing here. I'm going to subtract 2x. So I have 2y equals negative 2x plus 6. And finally divide by 2. So y equals negative 1x plus 3. Slope here is negative 1. Is that negative? And y-intercept is 3. Slope here is negative 1, and y-intercept is 3. These are the same graphs, so all I have to do is graph one graph. I have a slope, or sorry, y-intercept at negative 1. I'm going to go up 3, 1, 2, 3 over 1. Go up 3, 1, 2, 3 over 1. Both are the same, so I don't even have to do that second one because I have a y-intercept at 3, slope of negative 1. I did that all wrong, so I need to erase that. I apologize. I mixed up what was what. My y-intercept is 3, and my slope is negative 1. All right, here we go. I apologize. I started at negative 1 and went up 3 over 1. We have to start at 3, and we're going to go down 3, right 1. Down 1, right 1. Wow. If I go up 1, I have to go left 1. My graph should be heading down because I have a negative slope. At least I caught myself. We all make mistakes, so just remember that. I want you to try number 2, okay? Obviously, with this one, since they are the same graph, our answer would be infinitely many solutions. Try number 2. I would like to see it. Obviously, you already have this first one in y equals mx plus b. And then the second one, you need to work to get there, okay? Graph them and give an answer. When you are done with that, I want to see number 2, see what you got, and then your homework for the weekend is in your journal, page 150 through 151, the evens. All right, have a great weekend.